Okay, so let me finish up the discussion on 8.5 that I had started previously. This is part 2. We're still talking about rationalizing denominators. We haven't talked about rationalizing numerators yet. We'll do that in a few minutes. That's kind of part of this part 2. What we need to do now is learn how to handle denominators that consist of more than just a square root or a cube root. No, I feel like my handwriting has gotten worse since last recording. So we want to learn how to rationalize denominators with 2 terms. Okay. And I want to take a quick peek at how involved they get into this. Yeah, so for example, we need to be able to handle stuff like whereas before in part 1, we would have had just something simple like that. Now the square root of 3 is involved in a subtraction problem with another quantity. Similarly, we could just have something that is square rooted all over. And at this point, we don't care about that square root of 5 up top. That's not our problem. Our problem is whatever root or roots exist in the bottom. And, you know, just to make this interesting, I'm going to make these guys cube roots just to remind us that it's not all about square roots. Okay, so what we are going to have to recall is a formula that we memorized back in chapter, I guess it was 6. If we have a minus b times a plus b, that equals a squared minus b squared. And I think we learned it for the first time in chapter 6. It could have been earlier, maybe chapter 4, in this direction. And then when we got to chapter 6, we usually used it in the other direction, but formula works either way. It's just the context of the problem. So for now, what we are going to do is use this formula. So for example, let's just set up something easy, like the 2 minus the square root of 3 that I had in that denominator earlier. Let's just see what happens if the 2 is our a and the square root of 3 is our b. So I'll emphasize that. This is a, b, a, b. So what we need to come out with is a squared minus b squared. So that'll be 2 squared minus the square root of 3 squared. Okay, and I realized a minute ago in my eagerness to include the cube roots, I'm not going to include the cube roots. They actually would blow a huge hole in what we're trying to do here in this half of the section. So let me take them out. Okay, so we would have 4 minus, and then a square root squared just releases the inside. Well, not yet, Matthew, a little bit longer. So we would get the number 1. And now, okay, this is what was making me realize that the cube roots would be problematic, because I'm wanting to use this example, but it has to be square roots in the current context or it won't work. So you have square root of 6 plus the square root of 7. You've got the a plus b part. Remember that the order that you multiply these two things doesn't matter, because multiplication doesn't care about order. So Let's just see what would happen if we multiplied it like that. We would get a squared minus b squared, which would turn into a whole number 6 minus a whole number 7, which would be a whole number -1. So notice that whether you have 1 square root in your parentheses or 2, the a squared minus b squared thing is going to take care of any and all roots. Okay, so now let's see how to put this into practice in an actual denominator. So we are all the way over on page 475 in practice problem 4. Same directions as we had in the first half of this section. Now rationalize the denominators. Okay, so for a here, we've got number 5 on top, and then 3 square roots of 5 plus 2. Okay, since this is a 2-part denominator, it's an addition problem, we cannot do what we used to do at the beginning of 8.5 and zero in on the square root of 5. We used to say that since any fraction or any number can be multiplied by 1 safely, I used to say that we could just do that, but there is too much going on underneath here. If you tried that, you would still be left with square roots after this step. It will not kill off this entire denominator like it used to. So here's what we have to do. We still want to multiply by 1, but our cleverly disguised number 1 is going to be 3 square roots of 5 minus 2. So you can see, and I'm going to put parentheses here, 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 and here for extreme safety. Same quantity on top and bottom of a fraction means that that fraction absolutely has to be 1. Doesn't matter if that quantity is a little math problem in and of itself. Okay, so now we've got, this is a plus b, and this is a, this whole thing, 3 square roots of 5, minus b. So on the bottom here with the denominators, what we're going to get will be an a squared minus b squared scenario. So very carefully with use of parentheses, a squared, looks like that, minus b squared. And no, I haven't made any attempt at simplifying that yet. That'll come later. And then on top, I am just sort of sliding the two quantities together and not worrying about simplifying yet. Okay, focus is all on the denominator here. Okay, so as I square 3 square roots of 5, let me take that down to just the microscopic level, since this is our first example here. That's the same thing as 3 squared times square root of 5 squared. This is an application of an exponent rule. And then minus 4. At whatever point you feel comfortable, you can distribute that 5 very carefully through the parentheses at top. So 5 times 3 is 15. And 5 times 2 is 10. Okay, so we have 15 square roots of 5 minus 10. We do not care about the square root that we've introduced into the numerator. Our whole focus is on the denominator. Speaking of which, the denominator has 9 times 5 down there, minus 4. Okay, so drawing to a close here finally. 9 times 5 is 45. Minus 4 is going to give us a 41. Okay, and that's where we stop. We have successfully removed the square root in the denominator, and it was just so much harder because that square root was part of a little math problem. All right, so let's move on to part B here, where our denominator is going to consist of 2 square roots. Okay, so as before, I know I'm going to need that. And my whole theory here is just to multiply this fraction by 1, but to disguise that 1 in such a way that I'm activating my a minus b, a plus b rule. All the focus, all the construction that I'm doing is focused on the denominator. But what the denominator that I construct has to be mirrored by the numerator, otherwise the fraction won't equal 1. And then more parentheses needed. Yeah. And then this is a minus b. This is a plus b. So that leads to a squared minus b squared. That leads to our formula, which just keeping that going so we don't lose our train of thought, that leads to 3 minus 5. And that leads to -2. So we'll just go ahead and finish off the denominator. I know I didn't do that in the previous problem. Previous problem didn't have 2 square roots in the denominator. Okay, now up top here, this is not a nice cute formula. So this is going to require very careful distribution. So square root of 2 times the square root of 3, square root of 2 times the square root of 5. And then 5 times the square root of 3, 5 times the square root of 5. So 4 separate multiplications because we are foiling. Okay, so let me be careful here with my color coding, see if I can fit this all up here. Square root of 2. I don't even think I can do like I usually do. Okay, so square root of 2 times the square root of 3. Okay, plus square root of 2 again times the square root of 5. Okay, done with the square root of 2. Now we come and get that 5 times the square root of 3 plus 5 again times the square root of 5. Okay, so this mess that we've created up top, need to simplify it a little bit. 2 times 3 is 6, so I have like a square root of 6. 2 times 5 is 10, square root of 10. This is a whole number 5 outside of the square root of 3, and this is whole number 5 outside of the square root of 5. Yes, and they really do like us to leave it that messy. So as I recopy that, I've got that's what I've got. Man, is it ugly. That negative down under. So maybe things would be slightly less ugly if that negative came off to the side. So there's no like radicals up here that I could add together. So my best bet is just to leave that right where it is now. All right, and then finally here for this example, part C, I'm dealing with some X's and Y's now. Okay, got an addition problem shaping up underneath. So as I set up my fraction that's equal to 1, this is like a plus b. So I need to construct a minus b. And that requires me to mirror that quantity in the numerator. Okay. So here's hoping this will at least come out looking slightly nicer. So this whole thing is A. Of course, that's B. This whole thing is A. There's B again. So I need A squared minus B squared. So this is going to be A squared minus B squared according to the formula. And like I did a minute ago, let's just, should have done this from the beginning. Let's just kind of carry this out all the way. So this is like 2 squared times square root of x squared, kind of applying that little power all the way across, minus just y is equal to 4x minus y. And that's as far as we can take it, no like terms. Okay, up top, I have a little bit kinder, gentler problem here. We are just distributing 3 square roots of x. So 3 times 2 in the first distribution will be 6. Well, you know, let me not. We're still new at this, and I have room. Okay. Not sure what that was sitting there for. I was thinking, do I have another? Okay, Matthew, you can do that. 3 square root of x times the square root of y. Okay, just go ahead and show the distribution, and then I'll talk about what I was on the verge of diving into too early. So 3 times 2 is 6. Square root of x times the square root of x is just x. Minus 3 square root of xy. That's the best we can do. So there we go. Looks a little nicer than the last problem. So I'll take it. All right, now thankfully, that's as far into rationalizing denominators as they care to take us. Now they turn their attention to something that in my experience is far less common, rationalizing numerators. And I showed you some reasons why we might like denominators to be rationalized. I can't think of reasons why we would want numerators to be rationalized aside from them just making up problems to test our skills. So I'm just going to put a note that this is not as common or useful as doing the same thing to denominators. So if you do it now and then you don't really see it that much in the future, don't be surprised. All right, so this just requires us to kind of stand on our heads in terms of our thought process. So they want us to rationalize the numerator. Remember that, as I had put when we were learning about denominators, try to simplify those roots first. I'm not sure, Matthew, where'd that come from?
It's a gift card.
It's a gift card? All right, square root of 32 over the square root of 80. So we're going to try and simplify both of them, and then we'll turn our attention to the numerator and see what we need to do. Okay, so recall the perfect squares list. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on. So with 32, I think that's best written as 16 times 2. Notice that 4 would have gone into 32, but we want to find the biggest one on the list because there's 2 4s hiding inside of 32. So just isolating the 1 4 wouldn't have been good enough. Let's see, 80. Is that like 16 times 5? Yeah. Okay. And here, lo and behold, I mean, yes, the square roots of 16 are 4s, but because they're matching each other, we can go ahead and cancel them without even taking that simplification step. Okay, so this is what it leaves us trying to rationalize. So let's make a fraction equal to 1 and just multiply by the square root of 2 because we're focusing on the numerator. And I think we kind of get, that's really nice. Nicer than their example. We get 2 for the price of 1. We end up rationalizing everything here. Of course, root 2 times root 2 releases the 2. Oh, never mind. Sorry. I mean, going crazy here. 5 times 2 is 10. There we go. That's where we leave it. So the numerator looks great. The denominator doesn't, but for whatever reason, that's where they told us to stop. Almost. All right, so practice 6. This just really tests if we grasp rationalizing. We can handle it with the denominator and then turn right around and for no apparent productive reason, apply the process to the numerator where it is not usually applied. Okay, these 2 quantities, these 2 roots are already rationalized or already simplified. So we can go right to the part where we want to multiply by a fraction equal to 1, and we want to create that fraction by looking at the numerator. Okay, now remember, when we're dealing with cube roots, we need to come up with the cube root of some quantity cubed. That's our goal. Okay, so we have like 5 to the first and b to the first. And unlike when we had a 9 earlier, a 9 was 3 squared. So we actually had a head start if we called 9 3 squared, because then it was like we had 2 things. That's not going to work here. So what we're going to have to do, we have 1 5, we need 2 more. We have 1b, we need 2 more. That's what we're facing. Okay, and when we do that, and I'll just come underneath here so I don't have to erase the goal. We're going to have a cube root. Okay, so 5 to the first times 5 to the second equals 5 to the third. B to the first times B to the second, B to the third. And underneath, 2a times 5 squared b squared. Well, 5 squared is 25. 25 times 2 is 50. And then we have an a b squared. And I know that looks like something should come out of that 50, but that's because we're used to thinking about square roots. Roots don't work that way. Okay, so now we have a cube root of everything to the third power. That's just going to unlock that 5b. We have our brand new rationalized numerator and our ugly denominator. That from years of rationalizing denominators, that just feels so unfortunate. Okay, and that brings us to the final practice problem of ending this short little recording where we started it. This is a numerator that consists of 2 parts. So we've got square root of x minus 3 all over 4. I'm going to just go ahead and immediately enclose that. Okay, so this is like my a minus b. So when I set up my fraction equal to 1, focused on the numerator there, what I'm lacking is the a plus b. And because the fraction has to equal 1, what I set up in the numerator has to be mirrored in the denominator. Okay, so up top, we get a squared minus b squared. And underneath, at the moment, I'm just going to slide the 4 together with this quantity that it's about to distribute through in another step. All right, and then up top, the square root of x squared just becomes an x. 3 squared becomes a 9. The 4 distributes carefully through the set of parentheses in the denominator. And we're good to go. We have a rationalized numerator. All right, so that completes section 8.5, which means that when I get back on here and record again, they're going to want to turn us loose on some problems to solve, including some word problems, which I'll be very picky about. But yeah, that's an issue for another day. So let me go ahead and stop this and get it saved on YouTube.